In the world of electric cars, a silent war is happening right now. Two giant Chinese companies are fighting over the heart of your future vehicle, and the numbers they are throwing around sound like pure science fiction. Geely has just released figures that are making the entire industry stop and stare. They have an LFP battery that charges at 1,093 kilowatts. To put that in perspective, that is enough power to charge your electric car faster than you can fill up a gas tank at your local station. But the raw charging speed is only one part of this story. For years and years, battery engineers believed in something they call the impossible triangle. This was a rule that said you could never have everything you wanted in a battery at the same time. You always had to give something up. It was considered an unbreakable law of physics and chemistry. But Geely claims they have broken this law. They say their new battery does what everyone thought was impossible. And this is not a prototype sitting in a clean lab somewhere. This is a real battery in a real car being driven on real roads right now. If you are enjoying videos like this, please hit the like button because it takes a lot of effort to make these, and subscribe so you do not miss the next one. What you are about to hear is a deep look into how they pulled this off. We will explore the insane cooling systems, the chemistry that survives a bullet, and the 1 million kilometer lifespan. And we will see if this really beats the famous BYD Blade battery. To understand why this is such a big deal, you first need to understand the impossible triangle. The impossible triangle of batteries. Think about everything you want from a battery in your electric car. You want it to charge incredibly fast so you do not waste time sitting at a charging station. You want it to last for years and years without losing its ability to hold energy. And you want it to be completely safe, even if something goes terribly wrong. These three desires form what battery engineers call the impossible triangle. The name says it all. For decades, the belief across the entire industry was that you could only ever have two of these three things at the same time. It was treated like a fundamental law of nature, as certain as gravity. Let us look at why this trade-off exists. When you push a massive amount of electricity into a battery to charge it quickly, that flow of energy generates heat. The faster you charge, the more heat you create. And heat is the enemy of battery chemistry. It breaks down the delicate internal materials over time. So if you prioritize speed, you are slowly destroying the lifespan of the battery with every fast charge session. The battery works great today, but in 2 years it holds less energy than it used to. Now flip it around. If your top priority is making the battery last as long as possible, you have to baby it. You charge it slowly and gently to keep the heat down and protect the chemicals inside. The battery might last for hundreds of thousands of kilometers, but you will be waiting a long time at the charger every single time you plug in. Then there is safety. To make a battery as safe as possible, you might add thick protective layers between cells or use heavier materials for the casing. This adds weight and takes up space that could otherwise be used for storing energy. You get a battery that is very unlikely to ever have a problem, but it is heavier and less efficient. The problem is that every time you push hard on one corner of this triangle, the other corners suffer. Speed hurts lifespan. Lifespan limits speed. Safety adds weight and reduces efficiency. No matter how clever the engineering, you always had to pick your two and accept losing the third. This is why the news from Geely sent shockwaves through the industry. They are not using some exotic new battery chemistry that costs a fortune. They are using LFP, which stands for lithium iron phosphate. LFP is already known for being safe and durable. It is the workhorse chemistry of the electric car world. What it has never been known for is extreme charging speed. Geely's battery, called the Golden Brick, is already installed in the Lincoln Co. 10, a car that is being produced and sold in China right now. This is not a concept or a press release. It is real. To fully appreciate what Geely accomplished, you also need to know about the regulatory environment in China. The government there recently decided to get extremely strict about battery safety. A new standard, known as GB 38031-2025, goes into effect on July 1, 2026. Under the old rules, the requirement was basically a warning system. If a battery started to overheat dangerously, the car had to alert the driver 5 minutes before a fire broke out. The idea was to give you time to pull over and get out. The car would still burn, but at least you would be safe. The new standard throws that approach out the window. Now, a battery must produce 0 flames and 0 explosions for at least 2 full hours after thermal runaway begins. There is also a new test where they strike the bottom of the car to check for damage, and LFP batteries cannot exceed 65 degrees during charging. The philosophy has shifted completely. Instead of warning you about a fire, the law now demands that the fire never happens. Geely did not wait around for this law to take effect. They certified their entire battery range by May 2025, well ahead of schedule. They chose to hold themselves to the new standard before they were legally required to. And it is against this backdrop of stricter rules that they released the Golden Brick, claiming it conquers all 3 corners of the triangle simultaneously. The most attention-grabbing corner is the charging speed, and that is where things get truly wild. The 10,093 kilowatts charging marvel. The headline number is 1093 kilowatts. That is the peak charging power this battery achieved during official testing. But to really understand how wild this is, you need to look past the kilowatts and talk about something called the C rate. The C rate is a way of expressing charging speed relative to the size of the battery. If a battery has a C rate of 1, it means the battery can be fully charged from empty in 1 hour. A C rate of 2 cuts that in half to 30 minutes. Geely's battery hits 12C. That means the entire battery capacity can be filled in about 5 minutes. In the context of LFP chemistry, a number like this was unthinkable just a short time ago. It would have been laughed at as impossible. But here is the thing that matters even more than the speed. It is what did not happen during that charge. When you force electricity into a battery at these extreme rates, the heat does not just go up a little, it goes up exponentially. This is basic physics. The relationship between current and heat is not a straight line. If you double the current flowing through a conductor, the heat generated does not double, it quadruples. Think about a simple wire in your house. Send a small current through it and it stays cool. Double that current and it gets warm. Double it again and it could melt. This exponential relationship is the core challenge of fast charging. There is a well-known rule in battery engineering that makes this even more critical. For every 10 degrees, the temperature rises above the optimal range. The rate at which the battery degrades doubles. So even a small temperature increase during fast charging is not just a minor issue. It is actively destroying the battery from the inside. China's new law caps LFP charging temperature at 65 degrees. During the 1093 kilowatts charge test, the Golden Brick battery stayed at 64 degrees, just 1 degree under the legal maximum. Keeping a battery at 64 degrees while pumping more than 1,000 kilowatts into it is an extraordinary feat of thermal management. Geely achieved this through 3 separate layers of defense working together. The first layer is the physical cooling design. Most electric cars on the road today cool their battery cells from only one side. A cooling plate sits against either the top or the bottom of the cell. Geely took a different approach. They wrapped a liquid cooling system around both sides of every single cell. This doubles the surface area where heat can be absorbed and cuts the distance heat has to travel to escape. The result is a 35% improvement in overall cooling efficiency. A good analogy is cooking. If you set a hot pan on a block of ice, the bottom cools, but the top stays hot. Drop that pan into a bucket of ice water, and the entire thing cools almost instantly. That is the difference between one-sided and two-sided cooling. The second layer is software. Geely embedded sensors throughout the battery pack that monitor each individual cell dozens of times per second. These sensors are not just reading current temperatures, they are running calculations to predict where heat will spike next, before it actually happens. If the system sees that a particular cell is about to get too hot, it can adjust the cooling flow to that area preemptively. Each cell is also wrapped in an aerospace-grade insulating barrier that prevents heat from one cell spreading to its neighbors. The third layer attacks the problem at its origin. Instead of just cooling heat after it appears, Geely redesigned the internal architecture of the cells to generate less heat in the first place. They used a principle called Bernardi's energy balance to reshape how the cell handles the flow of electricity internally. By changing the physical structure, they reduce the heat created by electrical resistance and polarization before it even exists. They are not fighting a fire. They are making sure the fire has nothing to burn. This speed is also supported by a 900-volt electrical architecture in the vehicle. Most older electric cars use 400-volt systems. Higher voltage is like using a wider pipe to move water. The same amount can flow through with less pressure, and less pressure means less heat. The 900-volt architecture lets Geely deliver massive power without pushing excessive current through the wires. On the road, the results speak for themselves. The Lincoln Co. 10 can charge from 10% to 70% in 4 minutes and 22 seconds. If you want to go all the way to 97%, it takes just 8 minutes and 42 seconds. That works out to roughly 2 kilometers of driving range recovered for every second the car is plugged in. You could get enough range to drive for an entire day in less time than it takes to buy a coffee. But all of that speed raises an obvious question. If you charge this battery at those extreme rates day after day, will it fall apart in a few years? That brings us to the second corner of the triangle. A battery that lives 1 million kilometers. The second corner of the impossible triangle is lifespan. Everyone knows that fast charging usually kills a battery over time. If you use a fast charger on your phone every single day, the battery will not last as long. The chemicals break down. Geely says their new battery can handle 4,500 full charge cycles. A cycle is one full charge from empty and one full discharge back to empty. To make this number mean something in the real world, we have to do some simple math. Let us say an average driver gets about 220 kilometers of real-world driving range out of one full cycle. If you multiply 4,500 cycles by 220 kilometers, you get exactly 990,000 kilometers. Geely rounds this up and says the battery is good for roughly 1 million kilometers. That means you could drive this car for the rest of your life and probably never have to replace the battery pack. Most people do not even keep their cars for 200,000 kilometers. The car will fall apart from old age before the battery stops working. A 1 million kilometer battery is a massive leap forward for electric cars. But how do they keep the battery alive when they are pushing 1,093 kilowatts of power into it? Repeated ultra-fast charging causes physical damage inside the battery. There are two specific mechanisms Geely uses to fight this damage. The first mechanism deals with the physical swelling that happens inside a battery during fast charging. When electricity rushes into a cell quickly, the internal components physically expand, much like a sponge soaking up water and growing larger. If this expansion happens too aggressively, it can create tiny cracks in the internal structure. Once those cracks form, the battery starts losing its ability to hold energy. To handle this swelling, Geely built three technologies that work together. First, they developed a self-healing film, called an SEI film, that can actually seal up micro cracks on its own. If a tiny fracture appears as the battery expands, this film patches it before it grows. Second, they added a gel buffer layer around the internal components. Think of it as giving the sponge room to expand. The gel deforms and shifts as the battery swells, absorbing the mechanical stress so the hard parts do not crack. Third, they engineered special binders that act like flexible glue, keeping all the internal materials bonded together, even as they expand and contract thousands of times. Together, these three innovations let the battery swell and shrink 4,500 times without sustaining any permanent damage. The second mechanism is called S+ active coating technology. That sounds complicated, but you can think of it as sunscreen for the battery. The electrodes inside a cell are extremely sensitive. When huge amounts of electricity pour in during ultra-fast charging, it triggers chemical reactions that gradually wear down the active materials. The S+ coating is a protective layer applied directly onto the electrodes. It shields them from this repeated chemical stress, just as sunscreen blocks harmful rays from damaging your skin. Without this coating, the electrodes would degrade much faster under the punishing conditions of 12C charging. Because of these two mechanisms working in tandem, the golden brick can endure the most aggressive charging routine imaginable and still come out the other side with its health intact. It is like designing a running shoe that you can use for a marathon every single day for years without the sole wearing out. So, we have checked off speed and lifespan. But what about the third and most important corner? What happens if this battery gets into a bad crash? The safety standards in China are now stricter than anywhere else in the world. Geely did not just meet the new standards. They went far beyond them, testing their battery in ways that seem almost completely crazy. That brings us to the most intense part of this story. Safety beyond the law. The third corner of the triangle is absolute safety. This is where Geely really pushes the boundaries further than anyone expected. Their approach to safety starts with a philosophy that goes way beyond checking boxes to satisfy regulators. Since 2024, Geely has run 48 separate test programs, spending more than 48,000 hours putting batteries through hell. They destroyed 6,967 samples in the process, sacrificing cells and full battery packs to learn where the true limits are. What stands out is that 23 of these test protocols exceed what the new Chinese standard requires, and 12 of them are tests Geely invented internally. Nobody asked them to do these. They chose to because they wanted to find every possible failure mode before it could ever happen on a real road with real people inside. The reasoning behind this obsessive testing comes from a principle known as Heinrich's law. Originally developed from studying workplace accidents over many years, this principle reveals a clear pattern. For every one catastrophic event, there are roughly 29 smaller incidents and 300 near misses that preceded it. The takeaway is powerful in its simplicity. If you hunt down and fix the 300 near misses, the minor incidents never happen. And if the minor incidents never happen, the catastrophe never happens either. Geely applies this exact thinking to batteries. They probe for tiny weaknesses under extreme lab conditions so those weaknesses never turn into roadside emergencies. They would rather destroy thousands of batteries in testing than have one fail in a customer's driveway. Some of the tests they run sound more like a dare than a quality check. Take the crush test. They drive a 36-ton tank directly over a fully assembled battery pack. The weight applied is 1.8 times what the Chinese national standard demands. Any normal battery would buckle and fail under this kind of punishment. The golden brick holds together without any structural failure. Then there is the bullet test. Geely fires a 5.56mm round, the exact caliber used in military assault rifles, directly into a fully charged cell. The projectile travels at 920 meters per second and passes clean through the battery. Despite being pierced by a bullet, the cell voltage stays above 3.2 volts and nothing catches fire. The battery essentially takes a bullet and keeps working. And then there is the needle test, which is arguably the most brutal of all. They push 5mm steel needles into a fully charged cell from multiple angles at the exact same time. This is designed to simulate the worst kind of internal short circuit possible. After the needles are in, they watch the battery for a full hour. No smoke, no flames, no fire, no explosion. The battery just sits there, completely stable and quiet, as if nothing happened. Geely's commitment to safety extends beyond their own products. They actually helped write the new underbody impact test that became part of the Chinese national standard. And they took 12 patents related to battery floor safety and made them available to the entire industry, including their direct competitors. They decided that raising the safety floor for everyone was more important than hoarding secrets. Remember the new law requiring 0 flames for 2 hours after thermal runaway begins? Geely designed the golden brick so that if one cell experiences a thermal event, the heat stays completely contained. The aerospace-grade barriers and gel layers trap the energy inside the affected cell. The neighboring cells do not even register that something went wrong next door. The fire never spreads because the fire never starts. This completes the third corner of the triangle. Speed, lifespan, and safety all checked off simultaneously. But having an incredible battery is only half the battle. The other giant in China, BYD, has a famous battery of their own. Does Geely really come out on top? The answer might surprise you. The real-world battle with BYD. Now that we have seen how Geely solved the impossible triangle, we have to ask the big question from the title. Does this new Geely battery really beat the famous BYD Blade battery? To answer that honestly, we need to look at the comparison from multiple angles. Start with infrastructure, because that is where the gap is most striking. An incredible battery is worthless if you cannot find a charger powerful enough to use it. BYD has spent years building a proprietary flash charging network that is already up and running. They are even rolling out massive 1.5 megawatt chargers across Europe this year. BYD controls the entire experience from the car to the charger to the station. When you pull up to a BYD station, you know it will work because BYD built the whole system. Geely is in a very different position. Their megawatt charging relies on a partner called Ohan Energy, which is still in the early pilot stage. Ohan only has stations in a handful of cities, mainly Hangzhou, Beijing, and Shenzhen. Geely does not yet have the nationwide coverage that would let any driver anywhere take full advantage of the 1093 kilowatt capability. To close this gap, Geely signed a deal with NIO that lets their drivers access NIO's extensive charging network across China. It is a smart workaround, but relying on someone else's network is not the same as owning your own. Now look at the raw power numbers. BYD's system can reach a peak of 1500 kilowatts, which is higher than Geely's 1093 kilowatts. On paper, if you are just comparing the biggest number each company can hit on a test bench, BYD wins. But peak power on a spec sheet is not what matters to a real driver on a real highway. What matters is how quickly you can get from a low battery to enough range to reach your destination. And on that practical measure, Geely pulls ahead. The time it takes the golden brick to charge from 10% to 70% and then up to 97% is faster than what BYD's battery achieves. Geely gets you back on the road sooner, even though their theoretical peak is lower. So the answer to whether Geely beat BYD is not a simple yes or no. If we are talking about pure laboratory innovation on a specific battery cell, Geely accomplished something remarkable. They checked all three corners of the impossible triangle at the same time. They delivered speed, longevity, and safety in a single LFP battery, something the entire industry believed was impossible. That is a genuine engineering breakthrough. But BYD remains the undisputed leader when it comes to mass production and real-world infrastructure. Having the best battery in the world means little if you cannot plug it in everywhere you go. BYD's charging network is mature, reliable, and expanding fast. For a driver making a road trip across China or Europe, that matters enormously. BYD gives you the peace of mind that a charger will be there when you need it. This whole situation raises a fascinating question for the future. If a conventional LFP chemistry can already deliver this level of performance across speed, lifespan, and safety, why is the industry still pouring billions of dollars into solid-state battery research? The original promise of solid-state was that it would finally solve all three of these problems at once. But Geely seems to have done exactly that with a chemistry that has been around for years. Maybe the billions being spent chasing solid-state would be better used building out charging infrastructure, the way BYD is doing right now. For now, Geely has proven that the impossible triangle might not be so impossible after all. They pushed LFP chemistry further than anyone thought it could go, and the rivalry between Geely and BYD is only just beginning, which is fantastic news for anyone who drives an electric car. If you enjoyed this deep dive into battery technology and want to see more like it, please hit the like button, subscribe, and turn on notifications so you never miss the next one. It takes a lot of effort to break down these complex topics, and your support helps the channel grow. There are related videos on the screen right now if you want to keep watching and learn more about the crazy world of electric cars. So here is a final question for you. If you were buying a new electric car tomorrow, would you choose one with Geely's ultra-fast charging battery or one with BYD's massive and reliable charging network? Let me know your thoughts in the comments below.